we're finishing the rest of the questions in this video. So the question 21, it says we have this diagram. This is an isosceles triangle. So we are basically told that these sides there, they're equal. So we have PQ equal to PR. That's what we are told, and each side equals 7 centimeters, and we have this side equal to 35 degrees. So using as much information below as is necessary, calculate QR. So we want to find the side here. So there are two ways to go about it. I will show you the complication with the second method. But then right now, I just want to let you know that this is very misleading, because I think most students, what they would do is that they would recognize that this is 35 as well. You'd have 70 between these two angles, and then you'd actually have 110 here, 110 degrees. So you'd be tempted to use cosine rule for this, which is quite okay, but then it's a more complicated way to go about it. There's an easier way. There's a way that you can use is to just split this triangle into two. When you split it, since it's an isosceles triangle, it actually creates two right angle triangles. Okay, so this one would be 0.5 PQ. This one here. You can even label, since it's paper 1, you can even label on your paper. It's still okay. It brings clarity. So this is 0.5 PQ. So this one will be 35 as well, just like what we said. And so you have this one. It's a side which is adjacent to the angle. So you have adjacent, and this one, it's the height. So I use the mnemonic SOHCAHTOA, which means if I have adjacent and height, it means that I have to use cosine. Okay, so you just say cosine of the angle, which is the angle is 35, equals adjacent, which is 0.5 PQ. In our case, you can even say half, but the reason I didn't say half is I wanted to avoid creating unnecessary fractions, because I'm always going to divide anyway. So this one would be over 7. And when you isolate, you can multiply by 7. Let me actually do that. You can isolate PQ in one step by multiplying by 7 over 0.5. So you do this both sides. So 7 over 0.5 like this. So this one they cancel, these ones they cancel, and then you're left with PQ. So PQ would be equal to 7 over 0.5 multiplied by cosine of 35 degrees, like this. So here there are two ways to go about it. You can recognize that dividing by 0.5, it simply means multiplying by 2. Okay, multiplying the numerator by 2. Or you can actually multiply by 10 over 10. So the primary school way, you'd get 70 over 5. 70 divided by 5, you'd get 14. So it would be the same as saying 7 multiplied by 2. Okay, so it would be 7 multiplied by 2, then cosine of 35 degrees. One of the ways that you can know that you're on the right track is if some of these trigonometrical ratios are actually the given ones. So here, for example, we're given 0.82. So you're supposed to multiply here. So we're told, I think, in primary school, you should ignore the number of decimal places, just inventory them. So you'd inventory them by putting a 2 that signified 2 decimal places, then 0 here, then 32, that's 2, you get 3 sets of 10, then here you get 8 plus the 3 sets, you get 11, here you get 8, here you get 2. So you actually get, when you add this 2, you actually get 1148, like this. And you're supposed to put 2 decimal places as well, so it would be 11.48. So 11.48. Then you're supposed to put the units as well. So 11.48 what? The units would be centimeters. Okay. If you want, you can say x here. Then when you find the value of x, you're supposed to multiply that by 2, since this one, the length of PQ would be 2x. Okay, so you get this one. That's how you're supposed to do. Let me just show you quickly the complication with So this one will be 35 degrees. This one will be 110, as I mentioned earlier. And then you would have to say, okay, PQ, according to cosine rule. I'm just skipping here. I'm not going to state the actual rule. PQ squared would be equal to, it will be PR squared, which is 7 squared plus 7 squared, then minus 2, 7 by 7. Then you'd get cosine of what? Cosine of 110. So you'd get PQ squared here equal to 7 squared plus 7 squared. You can simplify this on the stage, it's still okay. Minus 2 times 7 squared. Then this one would be negative cosine of 70 degrees. So cosine of, if it's greater than 90, then the cosine of that is, you can say 180 minus the angle given, so it would be negative of that. So yeah, so you'd get 7 squared plus 7 squared here minus 2, 7 squared. Then you'd have to substitute this. It'd be negative 0.34. Then you'd have to simplify all this, of which you can see that this is pretty ugly. So that's why I was saying that the route of using trigonometrical ratios, that was the optimized route, and you can use that one anytime. So if you want, you can do this, especially in paper 2, then you can, because you have a calculator. But then right now, you're looking for ways to minimize the time you spend on any asset as much as possible. So question 22 says it's given that universal set is between 31 is included, and less than 37, that means 37 is not included. And we're told that it's an integer. Okay, it's an integer set. So this universal set means all the numbers that we are going to investigate, they are between 31 and 37, not including 37, including 31. Okay, then we're told that P is any number that's in the universal set that's a multiple of 3. Then Q is any number that's a factor of 99. Then R is any prime number. Okay, so the first part says list all elements of R. R is a prime number. So the first thing that I would do is to list the universal set. Okay, just write the universal set as clearly as you can. Why? Because you're going to use it a lot. Okay, so here it'd be, we say 31 is included. We're told that it's an integer, so it means that we are only concerned with numbers. So 2, 3, 34, 35, 36. We are not including 37 just because this is a strict sign. It means less than 37. It means 37 is not included. So elements of R would be whatever is in our universal set that's a prime number. So prime number means any number that has 2 factors only. The other factor is 1, and the other factor is, the one factor is 1, and the other factor is the number itself. So 31 has 2 factors, perfect factors. That's 31 and 1. So here we get this one. Anything else you don't include. 33, it's a little bit tricky for some people, but 33 is a factor, 11 is a factor, 1 is a factor. So you actually have 3 factors there. So it doesn't qualify as a prime number. So that's it for part A. And part B says write down the number of P union R in complement. Okay, so what I would want you to do is to do in steps. Okay, so you actually list the elements of P, you actually list the elements of R, then you combine, you get P union R, and then afterwards you take the complement. Okay, and then after taking the complement, you now take the number of P union R in this manner. Okay, step by step. So the elements of P would be any multiple of 3 in our universal set. So we'd actually take 33 and we'll check 36. That's it. Those are the 2 numbers that we can check from there. Then R, we already determined R is equal to 31. Then when we unite the sets, we get 31, 33, 36. Okay, uniting means we are simply taking everything has to be represented between these sets. Just don't repeat any numbers. And if you have a longer set, just write all the elements of the longer set. Then you start to compare with the other set, saying 31 is 31 included. So yeah, it's a problem that we will have to show another day. So this one would be for this part. So let me just wrap this part. So this one would be P union R. Then we want P union R complement. So it means any elements that we don't find there. So we have 31, 33, and 36. So 32 we don't find. We have to include here. We're comparing. 33 is there. 34 we don't find. We include. 35 we don't find. We include. 36. Okay, 36 is there. So that's it. So this one was 35. Okay, so now you want the number of P union R complement. So when you want the number, it simply means you want number, just a physical number. So here you have 3 elements. So that's your number. So the number would be 3 elements. Okay, that's it for this part B. Let's move to part C. So part C, you can say from, because you're uniting the sets first. We are checking it in steps again, just like what we did from B. We have P union R equal to, so don't write P U R, this is my mistake, P union R like this, it's different than a U. So P union R equal to, we have 31, we have 33, we have 36 like this. Okay, so you want to unite this with Q as well. So Q is a factor of 99. What are the factors of 99 in our universal set? It's obviously just 33 like this. So when you unite P union R union Q, you'd get the same elements here because 33 is sort of included already. So you'd get 31, 33, and 36 like this. And 36 like this. But you want the complement. So you want P union R union Q complement. Okay. So complement means you have to compare with the universal set, take the elements that are missing. So we'd have the same situation as we had previously. So it'd be 32, 34, and 35. Okay. So this is it. And then this would be your answer. Let's move to the next part. So question 23, it says we have a map. This is a very common question, okay, on scale. So let's quickly run through it. You're told to calculate in kilometers the actual distance between 2 towns. This is a very routine question, okay. So just take note of exactly what I'll do here, and then I'll explain why we do that, and it will be very easy for you. This is how you score like easy marks. Just going to change my pen here. So you have 1:75,000. Whenever you have a scale and then it doesn't have units, it means you start off with the same units. So already here they are talking of centimeters, so start with centimeters. 1 centimeter is to 75,000 centimeters. That's what it means. What you do is convert this bigger one to kilometers because you want to find the corresponding length in kilometers that for the 1 centimeter here. So you say 1 centimeter is to, you have 75,000 centimeters. You want to convert this to kilometers. So you first, centimeters, how many centimeters per meter? We have meter over 100 centimeters. So for every meter we have 100 centimeters. So this is more or less like one. This is called a conversion factor. Okay. So you can say 1 meter per 100 centimeters. That's what we are doing. We also want to change the meters as well to kilometers. So how many kilometers? 1 kilometer per what? Per 1,000 meters, like this. So you can actually, this is the second conversion factor. Why? Because you want to change from centimeters to kilometers in steps. If you want, you can divide directly by 100,000. Since this is a popular question, you can just, commit it to your mind that you are supposed to divide by 100,000 and then it would still be okay. But I just wanted to show you where this all comes from. So the meter cancels, and you can actually cancel the thousands here as well. So you're left with 75 divided by 100. So you're left with 1 centimeter is to 0.75 kilometers. Okay, so you're left with, let me just show you here. I had used a very lousy pen. So here you get 0.5 kilometers. This is your scale. Take note of it, because sometimes you have to use it several times. Okay, so when you have this, you want 40 centimeters. You want something corresponding to 40 centimeters. Simple ratio. This one would be more, just from primary school stuff. So if it's more, we say bigger number on top. Okay, bigger number at the top, smaller number at the bottom, just like that, and 75 kilometers, just like this. What do you get? 0.75 simply means 3/4. 3/4 of 40, it simply means 30. If you don't understand what I was saying here, just simply multiply 40 by 0.75. So you actually get 30. Make sure that you get this answer that we are getting here. So this would be the answer for the first part. And then the second part here, you see, that's why I was saying take note of this, just because you need to use it at least most of the times. So you actually have the actual area. So this area, you want it in the corresponding area in square centimeters. So how do you do that? You take the length ratio. The length ratio, that's the scale that you're given here. Okay, 75 kilometers. This is called the length ratio. I want you to square it. When you square it, you get the area ratio. When you cube it, you get the cube ratio. Okay, you get the volume ratio. So here you can say this is 3/4. Okay, or if you want, you can say 0.75, just like this, and then kilometer squared. That's what it means. Okay, you don't have to simplify this if you don't want. Why? Because we're going to have to cancel stuff as well very soon. So let's move to this part. It says we want the one corresponding to 22.5 square kilometers. That will be what, more or less. Here it's obviously more again. If it's more, man get a correction up. Yeah. Man get a correction up. So if it's more, you put a bigger number at the top. So bigger number, it's 22.5 kilometers square, okay, over 0.75 by 0.75. It is square kilometers as well. Then multiply by 1 square centimeters. So what you do here is you multiply by 100 the top part, so that you can clear decimals at the bottom. So you'd actually get 22.5 multiplied by 100. So you'd clear this one, and you'd say by 100 again to clear this one. So we multiply by 100 by 100. This one would be 75. This one would be 75. Then multiply by 1, so it'd be still this much. So 25 is a factor. Here you get 3. Here you get 4. Here you get 3 again, 25. Here you get 4. And it would amount to 22.5 multiplied by 16 here. Those times those. Then divided by 9. So 9 into 9, 1. It's actually a factor here. Into 8, 10. It's 2, remainder 4. Into 45, you get 5. So it's 2.5 multiplied by 16, which is 48, I think. Yeah, 2 by 16 is 32. Then half of that, that's 8. So 32 plus, which is 40. We said what? 32 plus 8, which is 40, yeah. So that's 40 square centimeters, like this. Question 24, okay, it's a travel graph. We have a travel graph. So the diagram shows a moving object decelerating from 30 meters per second to a speed 18 meters per second in 4 seconds, and then it further decelerates from 18 meters per second in the rest of the to rest in 6 seconds. Okay, then it says calculate the speed of the object after 2 seconds. So the speed of the object after 2 seconds. So we want the speed corresponding to 2 here. We want this, in other words. Okay, we want this. This is what we want. We want v here. So what you have to know is this one, it's a straight line. So straight line means gradient, it's always constant. So here your point, it's actually 2v. So if you can use 2v and one other point, let me just show you. So the gradient, from where to where, 0 to 4 seconds, okay, is equal to. So let's not say is equal to, since we are going to put equal again. We can put like this. That means we are following the gradient here. The gradient, you can put, this one would be 0, 30, okay, and this one would be 4, 8, 10, okay. So we're going to use these 2 points first. So it'd be 30 minus 18, 30 minus 18 here, divided by 0 minus 4, okay, for this part, which is equal to, we can use this 2 now. It would be 30 minus v divided by 0 minus 2, like this. So here you get 30 minus 18, I'm sure you get 12. So you get 12 over negative 4, like this, equal to 30 minus 2 over negative 2, like this. Then here you actually get negative 3, I think. So you get negative 3 here. You can multiply this to the other side. So you get negative 3, like this, and this one was supposed to be v. What am I doing? So this one is your v, and it would be 30 minus v. Here you'd get 6, and you get 30 here minus v, and then you'd get v equal to 30 minus 6, which is equal to what? 24 watt meters per second. Okay. So here we use the concept of gradient. Sometimes some people, they can actually find the equation of the straight line first, and once you find the equation of the straight line, then you substitute. But then that will take an extra step unnecessary, an extra unnecessary step. Okay, so let's quickly move to the second part of this. Second part says find the total distance covered in the 10 seconds. So 10 seconds means everything. So for a speed time graph, gradient means acceleration. The area under the graph, it means what? It means distance, okay, for a speed time graph. If you're given a different graph, different things. So here we're going to split it into, we're finding the area under the graph. So we're going to split this into 2 shapes. This and this one, we call it B. Okay, so you can say area equal to distance, okay, or you can say distance equal to area. It's more appropriate, which is equal to, this one is a trapezium. So area of a trapezium, it's half. So you can even label your stuff, and let's call this A. Okay, this one would be your B. So it'd be half A plus B times H. This one would be your H. And this one would be your base. This one would be your height as well. So this one would be your base for the triangle. This one would be your height. So half. So let's call this, since we already used B, let's call this C, okay? So half B, C, like this. So half base times height. So you'd get half, then A, it's what? It's 30. Then B, it's what? It's 18. Our height is what? It's 4. Then plus half. Our B is what? It's 18. Our C is what? It's from here to here, it's 6 seconds, okay? Don't be careful there. Don't take the whole thing. It's not 10, it's 6, because you're starting from here to here. Then what you get is half. And you get, I think, 48 here, 48 by 4. Then you get plus, you can even say 3 by 18. Why am I saying 3? Just because you can just get 3 quickly here. Then here you can also just get 2 here quickly. So you'd actually get 96 here, plus this one will be 54. And then when you add the 2, 96 plus 54, what do you get? You get 150. 150 watt meters. Okay, don't forget your units. Okay, that's it for this question. So just take note, it's a speed time graph. For speed time graph, A under the graph is distance. The gradient is acceleration. That's it. So let's quickly move to the next part. The next part says, okay. So the next part, okay, we're doing transformation. This one is going to be a bit longer just because I'm not really using, I have to use my computer to show you how to do it, but you'll be using paper. I'll try to be as clear as possible. So you want to, the diagram, it shows 3 shapes on a Cartesian plane. You want to describe fully the transformation, the single transformation, which maps shape A onto B, okay? So shape A onto B. So this shape, we want to make it to this. So the first thing that you recognize there is that this is a what? This is a transformation that doesn't change, doesn't distort the shape of, so there's a congruent transformation. So congruent transformations, they are rotation, they are translation, they don't distort. There's rotation, there's translation, and there's reflection, okay? So these are your congruent transformations. These shapes, it's not like any shape is bigger than the other or something. So that's how we know that this is congruency. The shape hasn't changed. So we have to figure out like which of these transformation is this. So translation, they'll be facing the same side. So for example, intuitively, I can tell that this could be translation. You're just moving the shape in one direction. So you don't expect it to have shifted like this. These, this marker here, if it's an envelope, it's to show you where the shape is facing. So it can be translation. It can be reflection. Reflection, it's as if they are looking at each other in the mirror. So it has to be rotation. But then if it's rotation, how now do you find so I can say, let me just write quickly here. So the transformation would be rotation, definitely. But then rotation, you have to describe it. So how do you describe rotation? You have to have the angle and the center of rotation. How do you do it now? So on your piece of, you can use your question paper. What you do is you just join corresponding sides. So I'm doing the same as well. So I'll be joining corresponding sides as well. So I told you that this is going to be a little bit longer just because I'm using, so just wait a bit. So yeah. So here, what you do is you draw the line, you join. So I'm going to join this line. Let me use a different pen. So let me use red here for this. So for this, we are going to use red. We have just joined this, okay. Then after joining this now, what you do is that you bisect the angles, but then you're supposed to write the perpendicular bisector. That's what you're looking for. So the perpendicular bisector would be, for me, it's 27 like this. So for perpendicular bisector, it should be meeting at right angles with your line here. So that's the line that you're looking for. For me, it should be this. And here it was easy to tell just because I had this side, this side, this side, this side symmetric. So they were actually crossing here. So my perpendicular bisector would be this one. Okay, so this is how you do it. Let me change my pen again. We are going to do the same thing, but we're going to do for two corresponding sides again, okay? So for this one, we are going to take this and this. So for this and this, we're going to take this one. I used a yellow marker here. So now we're going to bisect it as well. So yeah, so you're supposed to find, again, the center point. So the center point, where would it be? It'd be somewhere here, okay? Okay, so I'm going to write the perpendicular. This is the perpendicular bisector. I was striking the angles just like I told you. But you do it on your piece of paper, you'll be able to find the same. So see, this one, it's your center of rotation. So what we did was, okay, let me just switch off my ruler here. So this one is your center of rotation here. This one is your center of rotation. So what you did was join two corresponding sides, bisect. Join two corresponding sides, bisect. Even if you're a little bit off, you can actually see the the center of rotation there, that it was supposed to be here. So it would be, the center of rotation would be what? 2 minus 2, like that. So you could actually go back and write center 2 minus 2, like this. And you also have to find the angle of rotation as well. So how do you find the angle of rotation? So let me just use my ruler once more. So the angle of rotation, you join a corresponding side, you join it to the center. So it would be this. And you join another corresponding side to the center. Let me actually use a different color here. Sorry, I used the same color. It would be confusing for you. So I'm actually running out of colors here. But yeah, let me use this right here. So yeah, so this one would be your center of rotation. Your center of rotation, and when you join two corresponding sides, this angle would be your angle of rotation. Okay, this happens to be 90. It's not always 90, but this you can actually see that it's 90. So you are transforming from A to B. You're transforming from A to B. So this would be angle (90°) to the side, so it anti-clockwise. So anti-clockwise. So you have explained this transformation, okay? So it's a rotation, this is center, angle, and sense. So sense is it clockwise or anti-clockwise sense? Then that's it. The second part says shape B is mapped onto shape C by transformation P. And it says they're just the same, describe fully transformation P. So this one was a bit easier. So that's what we are saying at the beginning, that this transformation, it's definitely a translation. B to C, it's definitely a translation. Why? Because we can actually see that this is a shift. It could be rotation, reflection, or translation. And what we notice is that the sides, they're facing the same side, so it should definitely be a translation. So a translation vector would be this one. So just quickly take note of where you're going exactly. They say from B to C, so it should be this direction. So what's the vector here? The vector will be this. Okay, let me just change my pen real quick. Yeah, so the vector would be here, going up, here, going across. So you say the transformation, it's B, it's a translation. After saying it's a translation, you need translation vector. So vector is what? So here it's minus 1. Okay, from here to here it's -1, this vector. So you get -1, then so -1 this part on the x-axis, then here is 3, so 1, 2, 3. So this is your translation, and this is your translation vector. Okay, so let's quickly move to question 26. It says in the diagram, this is a circle, TAS is a tangent, and you have circle, it's a tangent at A, and you have these angles given. So BAS, it's equal to 49. So this one is 49. Take note of it. This one is 54. So we asked you find, I'm just going to write them down somewhere so that we can work on only one page. So we are supposed to find OAB, AOB, and we're supposed to find ADC, and finally reflex AOC. Okay, so that's a buzzword there, reflex. Take note of it. Okay, so we're going to move quickly to the diagram. So first part that we have to find is OAB. Where is OAB? So OAB, this angle here. So this angle here, when it radius meets, or a radius or a diameter meets a tangent, it's always 90 degrees, okay? So you actually have 49 here, so this one would be 51, such that the two, they add up to 90. So it's 90 minus 49. You don't get 51, you get 41 here. I'm sorry about that. So you get 41 here. Then after you get 41 here, the next angle that you're supposed to get, sometimes if you can, just follow the sequence that's given. Sometimes it's given in the order in which it will be easier for you to discover the angles. So AOB like this. This one will be easy to discover. Every triangle formed from the center is an isosceles triangle. And the base angles, they're equal. So this one will be 41 and 41. That's 82. And 82 from 180, you actually get 98. So this one will be 98 degrees here. So let me just write quickly. OAB is equal to 41, we said. And the B part, AOB is equal to 91 degrees. The C part, ADC, so ADC, this angle here, that's what we have to find. So this ADCB, ABCD, it's a cyclic quadrilateral, okay? So in a cyclic quadrilateral, opposite sides, they add up to 180, okay? So you have 41 here and 54. So you actually have 95 all in all, and 95 from 180. So 180 minus 95 here. I want to find what we get. So 180 minus 90, you get 90. Minus 5, you get 85, okay? So this one would be 85 degrees. So ADC, 85 degrees, like this. So this one was a bit easier. So that's it. And we have to find reflex AOC. So AOC, when they say reflex, it means it's between 180 and 360, okay? So it's this angle here, not the inside angle. So what you do is just find the inside angle. The inside angle here, angle formed at the center. This angle here, angle formed at the center, it's twice the angle formed at the circumference. So it actually get 85 by 2. 85 by 2, it's 170, I think. Yeah, it's 170. Then when you say 170, to get the reflex now, you would say 360 minus 170. So 0 here, that's 9 here, that's 2 here, that's 190. So reflex AOC is equal to, it's 190 degrees. So this is it. Let's quickly move to the next question. Next question says, if this is equal to, this matrix is equal to this matrix is equal to this, H is equal to this, find F plus, a part says find F plus 3G. So it's equal to F, you have 3x minus 4 minus 6 here, plus 3, what's your G? 3 minus 2, 2, 1, just like this. And you have, this one would be 3x minus 4 minus 6, like this. Then plus, this one would be, this scalar multiplies each and every element there. So you'd actually get 9, here you'd get 6, here you'd get minus 6, here you'd get 3. So when you add the 2, you'd actually get 12 here, because you're just adding corresponding elements. So you'd get x minus 6 here, you can't simplify. Then you get 2 here, then you get minus 3 here. And then that's it. This is your part, you're done. And now it says the value of determinant x is equal to this, or f is equal to this, minus 14. So find the value of x if, I think, the value of x if, I think it's we're supposed to read if. I don't know what's happening with my editor. But yeah, so here you actually take f, the determinant, which is equal to what? 3 multiplied by negative 6. So minus, there's a minus which is permanent there. before you even touch anything. So everything else, they multiply as well. So this times this minus this times this. So there's a minus which is permanent there. Take note of it. It's very, very important. Some people, they get it wrong because of that, by forgetting that there's a minus there which is permanent. Here you get negative 18, here you get plus 4x. So minus and minus, you get plus, then you get 4x here. Then you get minus 14 here, you get 4x here. Then you get negative 14 plus 18 here, and you get x. Okay, let's just keep on with 4x equal to, you get 4 here. You divide both sides by 4, you get x equal to 1. Just like this. And then you're done. Okay. Let's quickly move to the C part. The C part says find GH. So this is simple matrix multiplication. If you don't know exactly how to go about it, this one will be 2 by 2. It's a 2 by 2 matrix. This one, it's a 2 rows here. 1, 2 rows by 1 column. So it'd be 2 by 1. So you just marry these ones, these two. And then the remaining, they are the order of the matrix. So you actually get a 2 by 1 matrix. So 2 rows by 1 matrix by 1, 2 rows by 1 column matrix. So you'd get the same as this matrix here. So you'd actually get 3 times 7, so row by column, plus minus 2 times 1, like this for this part, this row by this column. And then for this one, you get 2 times 7 plus 1 by 1. So you'd actually get 21 minus 2. Here you get 14 plus 1. And then you get 19, 15, like this. And then obviously you're done. So yeah, this was great. I really liked this paper. It was challenging, and it was very tricky as well, which was cool. It was exciting. So just make sure that you get some of the elements. I'm sure right now you have a hang of it. There are some questions that just repeat, like simultaneous equations. Make sure you lock in on them so that you can get some of those free marks, and also ratios. And also we looked at transformation as well. Scale, it's also very popular. So that's it for this paper. Please make sure you like, share, and subscribe. And we value you and we love you. So cheers. We'll catch you in the next video. Yuba out.